communicate to something we call the control plane. And the control plane authenticate users and then assign an IP address, and then in the next turn allocate the user plane, which is the main focus of today's presentation. And the user plane is the entity that actually moves the payload from the base station, or actually the end user, to the internet. And in order to actually get this working, we have a protocol called PFCP that we use, that is a UDP protocol that actually set up or configuring the user plane in order to get the payload working from the end user to the internet and back. And what we do, we actually have a bunch of rules within this protocol that is used then to configuring what we call the user plane, which is here. So the first part is the packet detection rule, which is used to match incoming traffic to our part to an actual end user from both the internet direction and the radio network. And then we have the forwarding action rule, which tells us what to do with the payload when we have actually matched it to a subscriber and how we should forward it, or if we should drop it or redirect it. Then we have usage reporting rules, which is basically how to charge for the user or report statistics, how much bandwidth this user has used or how long he has been active. Then we have another set of rules, which is we call it QER, quality enforcement, how to prioritize the traffic in the network and all the switches. So we normally want higher priority for voice than kind of streaming data. And finally, we have the bars that we call them, buffering rules. And that's for traffic coming from the internet to our data plane, where we don't really know where the user is. So we need to find the user and page the user to actually be able to send the data to it. And in that case, we need to buffer this data in order for us to actually communicate with the end user or the mobile. And then we have rules for that one as well. So when everything that is done, then you can send traffic from the end user to the internet. So it could be browsing, streaming video, phones, or basically anything, any kind of traffic that we send from the end user to the net. Yeah, and if you have some questions during the presentation, you can put it in the chat, and my colleague Danny Trejo will try to answer them. And for those questions that wasn't answered in the chat, I can try to answer them in the end of the presentation. So this is basically about what Packet Core is, moving data from end users, phones, tablets, critical IoT devices towards the internet, or a corporate network. It could also be, of course. I'm back. So just to get a little bit of grip, how big is Ericsson Packet Core in the world? So currently, we have more than 300 telecom vendors for our traditional 3D and 4D deployments all across the world. And we also have close to 100 of these that actually have gone into this virtual world where actually are starting using VMs instead of dedicated hardware. And it's a strong trend that many of our customers want to go in this direction. Then we also have something called VoLTE and Wi-Fi. So you can use Wi-Fi to set up phone calls. With quite a few of our customers doing that one as well. And now lately, IoT, Internet of Things, are taking off. So we have more than 40 live networks there as well. And the strongest trend right now is 5G. So we have seen over 100 of our customers are trying this out, and over 10 of them are already live when it comes to 5G on these new container-based platforms, and even more are have deployed 5G with the radio network and still using the legacy core network. So overall, this corresponds that we have more than 40% of the world's total mobile data going through the products we develop here at Ericsson, which is our user plane now. And that, as I said, is any type of data like voice, streaming video, and so forth. So that's a little bit about the background to Packet Core. So now I'm going to go into the challenges that we have seen moving from a physical world into a cloud-native world. So we started back in 1997 when we started on the first 3D products. And we still have those physical hardwares that we used to back then currently, but of course they have evolved over time. And those are typically very high performing edge routers that Ericsson has developed the hardware for as well. And those are super reliable, but of course they are very expensive. And since it's a physical box, you can't really scale them. But from a test perspective, it's a very well-defined environment. So for us, it's very, yeah, it doesn't require that many test cases compared to the whole thing when it. But then telecom operators in general are quite late to adapt to change because they're really traditional. But for the last at least 5 years, we have had virtual deployments as well. So meaning virtual in our world is that we have replaced VMs instead of our physical boards and deployed our products in data centers instead. But we still, from the end perspective, have the same look and feel when it comes to operating the system, having the same CLI, same counters, very much the same look and feel, meaning that we also could use this exactly the same amount of test tools on this vertical deployment that we already had on our physical ones. So from a testing perspective, moving into the physical world, of course, it's not that part that is the challenge part. This is that now we're running in VMs, right? And in VMs, you can have different VM sizes when it comes to how much memory you use and how much vCPUs you allocate to the VMs. And you can also be running on a different lower level infrastructure like VMware, OpenStack, and so forth. That, of course, you need to test them. So, yeah, some challenge in this area, but basically not too much that we really can't handle with some effort. So the next thing that actually happened before moving into the cloud native world was that the standard for 4G changed. So before 2019, the control plane and the user plane were actually together. So it was kind of one monolith that you could scale within your physical node or your VM, so to speak. But it's still the same kind of product, but just different functionality of that product. But in order to cope with 5G and escalating volumes in traffic in 4G, the standardization was that we need to break these parts apart so you can have more user planes serving on one single control plane. And that caused a lot of challenges, particularly for Ericsson then, because we had a very efficient, tightly integrated user plane part of our product together with the control plane. So we need to completely redesign everything that we did in the user plane in order to be able to use these kind of rules that we get with the PFCP protocol. But that was mainly a design challenge. It was not so much a test challenge. But now and then, of course, you still need to be able to support the old ways. So, and the old ways that's working tightly together with the user plane within one single product or node, as we call them, or apart. So you need to be test them both together and apart and independently. And that, of course, open up to a lot of possibilities of testing our products now, since instead of having just one way, we kind of have 4 ways to test them. So, yeah. But, I mean, that was mainly a design challenge. And the next thing that actually happened nowadays is the 5G then. It comes, and now we're actually going cloud native. So we have taken our software and kind of broken it apart into microservices, going the full cloud native way, moving into stateless. services that actually can scale independently and have independent life cycle management. And of course, going into that direction, we can't use VMs anymore. So now we're working with containers, and we're working with Kubernetes and Kubernetes pods to actually run our software on. And this whole shift going into Kubernetes opened up a lot of possibilities, but of course a lot of challenges. And while doing this, we also aligned to having the same kind of configuration management and performance management on all Ericsson products, basically, to get the same look and feel. And we actually had a completely new test environment for this kind of setup. And of course, when we have this new type of environment, we have this type of infrastructure that we're working on that requires a whole new set of test cases. So there we are currently, and we put a lot of effort into getting up to the same speed when it comes to have the same amount of testing on this new environment. And of course, it's not just running OpenStack. We do have so many variants of causes now, right? So we do have, and cause is the environment that we are running in. So we have AVS, we have Azure, we can run it on our products on bare metal, OpenShift, and our internal cause that we call CED. So this is also kind of a new aspect of testing, because we need to test a lot of combination on these different causes as well. So it's there where we're currently at. That's a big challenge for us right now. So moving a little bit into the testing pyramid then. I guess that those of you who are working in testing probably have seen a variant of these at least. The agile testing pyramid. So the basic is that you should have more testing and finding more faults on the lower level. And as you progress along this pyramid, you will find less faults, and it's also hard or more expensive to find them and correct them later up in the pyramid. And yeah, and of course this also goes for functional and non-functional testing. So we have basically 6 levels of testing. The first one is the lower level one, the unit level. That is, basic testing that every designer probably knows about, writing design tests or unit tests. Then we have one level that I will dive into a little bit more in detail, which is the microservice testing, or the high-level design testing now. And then we have the possibility to test multiple microservices together for some scenarios. And this is quite new for us, so we don't have that much testing in this area, but it's a very interesting area to continue looking into and develop. Then we have a lot of testing on what we call target, meaning to actually deploy our product as the customer and do testing on that one. So here we do all our non-functional verification on this level. Then in the end, before shipping it to the customer, we put all of our different products together into a complete network end-to-end solution, where we're basically simulating only the radio network, and then have the real software running together. And at the end, before the customer deploys it in the network, they also want to run some tests of their own. Now I'm going to look a little bit to the functional testing that we do then. So this is our function testing level that we call signal flow testing. So what we do is that we actually bundle the binary, the production binary of the microservice together and link it together with the test code. And then we get one single executable that we can run. And what we do, we simulating kind of everything, all the signals going in and out of our microservice. So it could be either we call it NFAPS. So this could be an external interface for our product, or interfaces between different microservices that you can simulate using this test suite. And then
yes, would you mind moving the share bar at the top of your screen? Because
okay, is that one in the way? You put it up here, maybe?
Well, sometimes, yes, that's a better position. Thank you very much, because sometimes
sure.
really useful information in your titles too.
Yeah, hopefully they are somewhat useful at least, yeah.
To me, they are.
Yeah. As I said, we do have external interfaces for the AMP product that we can simulate, or interfaces to other microservices that we can simulate using these test suits then. And we can also simulate, let's see, changing. So here we bypass the IO layers of the microservice, but everything is the same. And we can also manipulate the time from the test to simulate the expiry of timers and so on. And these are quite fast, at least. In general, they take only 50 milliseconds to run, which is much faster than if you would have run functional verification on our proper products. And then we can get the PCAP files, signal flow charts, and log files per test case. So this is the main functional testing that we do. And the big benefit of this is that we can run it on basically any Linux kernel. So we can run it on developers' computers, for instance. So we don't need any kind of dedicated hardware to be able to run the function testing. The next thing is the verification on target, as we call it then, which is our non-functional system verification. So here we have a tool called Dallas, which we have developed in-house at Packet Core. And the benefit of this one is that it can actually keep track of our feature development. And it's so feature-rich and powerful in that sense that no other third-party product can really compete. Maybe in performance, but never when it comes to features. And what it can do is that it can basically simulate a complete network for us. A complete network with a complete radio network, all the surrounding nodes that we have, and millions of users. And they are also behaving as they would in a live network and sending exactly the same payload as in the live network. So you can record payload, what the end user sends there, and actually feed it through our system through this tool. And we call it traffic model. So we can actually build, depending on what type of customer scenario we want to test. So we can build their network within our test tools, so to say, and simulate the traffic and everything going on into their network. And we have also scenarios where we actually try to get as good test coverage as possible and actually enable as much features as possible and then feed traffic on and testing it that way. So a little bit of the expectations when it comes to the non-functional part from our customers. So when we normally deliver software, we are never allowed to degrade the capacity. Meaning that the newer version should be able to carry as much end user payload, or as we call it. And of course, the amount of requests coming from the control plane should also be the same or better. So, and when we measure capacity, we normally talk about CPU usage and the memory usage. So we have a lot of testing in this, what you call the capacity area. Then we have something called stability. And since we're talking about telecom grade systems now and not just datacom, we have super strict requirements on how well and stable they must be. So we need to comply to something we call 5 nines uptime. And that basically means that we can only have 5 minutes of unplanned downtime on a whole year, which is a really strict requirement. And we have tests we call stability test standards, where we actually use these traffic models that I described that get the surrounding system to behave as a proper radio network. And of course, we can't really run it over a year. But I mean, we have long-term tests like 24 hours or 12-hour test cases, where we look at the characteristics like CPU usage and memory usage and a lot of other things here to see that the system is stable over time. We also have an area called robustness, which is a really important test area. meaning that the product that we deliver needs to be able to recover with minimal system impact or to the end user, which is kind of fluffy. But I mean, here we test all type of failures that we can have, basically, like process kills, board failures. We can have complete outage and so on. We also have one area called maintainability, and that covers changing the main software version of our product. We're going to a new software release or going back to an old one then. And we also test scale in and scale out. So if, for instance, we need to plug in more VMs or boards or to handle capacity, we should be able to do that without any impact to the existing users that we have. And then we measure these key performance indicators then. So those are particular packet loss is one of the important things. So you're not allowed to drop any kind of packets within your system due to any of these events that I just described, like changing or scaling in or scaling out, because these are planned activities. Okay, so next thing is what we call the confidence level when it comes to the software. So we have a ladder, confidence ladder as we call it, for our software. The first one is the C level, meaning that in order to be able to deliver any code from the developer, all unit tests and functional tests must be passed. So it's a quite strict requirement. And then when that is done, you have passed confidence level 0 then. Next one is confidence level 1. So when the code has been pushed for your microservice, you build that microservice. And then you test it together with older microservice or microservice that you know are working together with the new version. And if that is passed, then you can integrate this new version of the microservice together with the other one to a complete product. And this is this new version of the complete product then, with this new microservice that is getting tested in C2. So when all of the tests that we have defined for C2 are okay, then we can release it. And the final step is what we call C3, that is the end verification at the customer site. Then we have gone through the complete flow. So short about our cloud native test flow then. So it begins here when a developer pushes their code for commit. Then we run our unit tests, and then we run our microservice tests then. So this is basically all our function testing that we do. And then if that has passed, then we have reached confidence level 0. Then we have something called staging before actually integrating the new version of the microservice. So that is time box be around 30 minutes. And now we actually deploy a complete system with the new microservice and do testing on it. And if that is successful, then we can integrate this new version to the main Helm chart. We're using Helm charts together with Kubernetes. And then we do this non-functional verification, this system testing then. And then in the end, we are able to, when all the tests are done and passed, we are able to release. Then we are at C2, and then we're at the customer site testing before reaching level C3. This is a kind of different view on it. So we are using one track in our development. So we have one master track that everyone is delivering into continuously. So even though a feature is spending over time, they're continuously delivering into this one track. And we have multiple feature teams working in parallel, all delivering into this one track. And at the same time, we have corrections coming in to this track as well. So a lot of things happening on this software track. And on this track, then we have different type of test scopes. So we have scopes that runs hourly. We have scopes that runs daily and weekly, and even further apart. And since we have this kind of high requirements on our products, and we have this continuous delivery to our master, we need to actually branch out before delivering. So we do that every month, and we create a release branch. So we can see this is the master track going on here. So here we have what we call the CI scope, which is basically the things that continuous integration does. So we do it every hour. Then we have daily scopes. We have KPI scopes where we measure that we don't degrade capacity. And then we have our weekly scopes continuously going on this master track. Then every month or every second month, we branch out. And now only corrections are allowed to come in on this one. And here we also extend the scope a bit with some other type of testing that we normally don't do on this. Currently, we have the vulnerability testing doing on this, but we are kind of changing our way of working with, so we will have the VA testing on this branch as well. And we'll also test the new features that we have developed since the last branch out on this one before delivering. So, reaching down a little bit. So when it comes to the number of test cases, last I checked, I think it was about 3,800 now, I think, of these functional test cases. So it's not that much, but I mean, it's growing rapidly since the user plane is a completely new product as well. And the good thing here is that we actually have the same business logic for both the containerized user plane and the physical or virtual, as you call it. So you don't need to duplicate that. When it comes to the virtual or the container-based, this is, as I mentioned in the beginning, completely different frameworks. But already now you can see that the number of test cases here on this container-based is bigger than the old legacy ones. So it grows quite rapidly here. And when it comes to the total user play development, we are roughly around 32 teams, I think now, distributed over Gothenburg, Hungary, Madrid, and Beijing. And here are a few links for you if you want to look more into detail what we are doing. So I think I'm close to wrapping up now. So time for some questions, maybe.
Thank you very much, Mathias. It was really interesting and huge numbers. I made some calculation, 3,700 test cases plus 200, 50 milliseconds each. It's still only 5 minutes of testing. That's really luxurious to a lot of us.
Yeah, but I mean, it's quite small compared to the control plane because I think they got 18,000 test cases with the new test framework and about 18,000 testing on target.
Okay, so there's
because they have so many more interfaces. We only have basically 3 external interfaces on our product, but still a lot of many test cases. So
one thing that strikes me when moving to containerized Kubernetes platforms like this, you might encounter sys events like full disk, like some out of memory exceptions, more or less platform dependent stuff. Are you testing for those too?
Yeah, we just started to actually use a tool called Litbus, which is kind of a chaos monkey that we run on our products in order to kind of test these with memory hogging, CPU hogging, low network disruptions and stuff like that. So now we're actually going from a more constructive or planned testing into this kind of more chaos monkey testing to try to find faults.
I see. And speaking of that, you briefly mentioned vulnerability testing. You did that in the pipeline, which makes I found that a little bit interesting because not a lot of people, organizations manage to do that.
Yeah, we're just starting that one up for our products. I mean, for the products that are, we have different development partners within Ericsson. So those that are generic for different products have had this for a while, where they actually put the VA testing within their development pipeline.
Yeah.
And we are trying to break down our product to have these kind of pipelines for all our microservices we are developing at Lindholmen as well, and getting this Defense 6 and Nessus and stuff into those development pipelines.
Yep. And now it's lead time, 13:37, but let's skip now. I remember working for Ericsson more than a decade ago, but from the radio perspective, this packet core takes care of everything from the radio networks and down to the internet.
Yep.
I assume. But you also mentioned you were working with UDP, so there's no guarantee for all my data to actually end up on the internet.
Yeah, but the UDP is only between setting up the sessions between the control and user plane.
Okay.
So to able to provide the connection between the users and the internet. So, and we do of course have resending mechanism and stuff like that in place.
So I shouldn't blame you for not being able to
course,
connect the times.
Yeah, and then of course we can transport any type of data through our data plane. So this is just between the connectivity between the controller and user plane, not in the payload pipeline for the end user.
Yeah, and tripling the number of test cases by going to supporting both hybrid, cloud, and on-prem. I assume that would be a temporary solution, but probably for a while.
We do have a lot of customers that are really conservative and still want to have this old way of doing it, still keeping this dedicated hardware. And then they have super aggressive customers that want to go cloud. And of course, we need to have testing all the way to covering this and make our product work on kind of any type of deployment.
And you have a long roadmap too. So it's
yeah, we do have a long roadmap with new features. And also a roadmap with some of the features that we really couldn't squeeze in when we actually broke this user plane apart from the control plane in the beginning that were proprietary stuff. So we have a lot of stuff and roadmaps and features requests. Yeah.
Yes. Thank you very much. We'll be switching the speaker pretty soon. Just going to appreciate that you are naming your confidence levels from base 0, because that's a good sign. 0 confidence.
Yeah, we need to start somewhere. And starting with 1 is probably not a good thing. You need to start at the bottom, right?
Yeah. Thank you very much. Big hand from Mathias.